Welcome again to the Australia studio for Astronomy Daily for another week. It's the 5th of May 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, we're back again, and please welcome to the studio my good friend and digital pal, Hallie. How are you going today?
Always great to be here in the studio with you.
Oh, that's nice to hear.
So, what's on the menu today, my favorite human?
Well, Hallie, I'm glad you asked. Did you know there is an old Soviet spacecraft about to re-enter back to Earth?
And not because it's part of a mission.
No.
Just because it's old, right?
Oh, Hallie, only you could get away with a comment like that.
Oh, stop it.
Yes, I remember you talking about space junk in the tea room. Yes, we won't go there.
And don't forget about that story about the U.S. Army creating space jobs.
Yes, space jobs for enlisted personnel. That's the one.
I can't wait to hear just what that's all about.
I know, Hallie. They already have Space Force. So, what else is going on over there?
I know.
And how about this one? Astronomers have come across a planet that's orbiting a star.
Okay.
Yeah.
That's a very normal kind of story, isn't it?
Yes, but this star is hurtling out of the galaxy at an unbelievable speed.
Okay. I just looked at the file. That's a fast star.
Well, I've actioned that one for you, Hallie.
I'll bring that story soon.
And finally, we'll be going all the way out to Io and Jupiter. Some of the best stories come from that end of the solar system. Is there an end?
The little probe that just keeps on giving.
That's right, Juno. Juno has been revealing the stunning imagery and data about Jupiter since 2016. It's been examining the gas giant's atmosphere, auroras, and mysterious core, all this while coping with the harshest radiation conditions in the solar system. How about them apples, Hallie?
You can keep those apples, thanks. I'll stick to planet Earth.
Yes, I'm a groundhog as well. So why don't we get on with it, my data-driven damsel of out there astronomical awesomeness. Let's hit it.
Okies. Astronomers have observed hypervelocity stars before, but NASA scientists may have just identified a truly extraordinary system. They've found what appears to be the first known case of a super-Neptune exoplanet orbiting a hypervelocity star, a star hurtling through space at extraordinary speed. This remarkable find could reshape our understanding of how planets form and survive in extreme gravitational environments. The fact that a planet has remained gravitationally bound to such a fast-moving star challenges existing models of stellar and planetary evolution. However this system formed, it's astonishing that the planet has managed to stay in orbit through such a tumultuous journey. Hypervelocity stars are rare celestial objects that travel at incredible speeds, often hundreds of kilometers per second. These stars are usually ejected from their home galaxies by powerful gravitational interactions, such as close encounters with supermassive black holes or other massive stars. Some travel so fast that they can escape the gravitational pull of the Milky Way entirely. Studying these runaway stars offers valuable insight into the structure and evolution of our galaxy, the behavior of black holes, and even the distribution of dark matter throughout the cosmos. The details of this groundbreaking discovery were published in the Astronomical Journal, led by astronomer Sean Terry of the University of Maryland. The research describes a low-mass star moving at approximately 540 kilometers per second or 1.2 million miles per hour, with a likely super-Neptune-sized planet in orbit. If placed in our own solar system, this planet would lie somewhere between the orbits of Venus and Earth. According to Terry, this is likely the first planet ever discovered orbiting a hypervelocity star, a finding that pushes the boundaries of what scientists thought was possible in planetary dynamics. Finding objects like this in space is tricky. This object was first seen in 2011 following analysis of data from the microlensing observations in astrophysics survey that had been conducted by the University of Canterbury in New Zealand. The study had been on the lookout for evidence for exoplanets around distant stars. The presence of a mass between Earth and a distant object creates these microlensing events. As such, when a mass passes between us and a star, its presence can be revealed through analysis of its light curve. In the 2011 data, the signals revealed a pair of celestial bodies and allowed the researchers to calculate that one was about 2,300 times heavier than the other. The 2011 study suggested the star was about 20% as massive as the Sun and a planet 29 times heavier than Earth. Either that, or it was a nearer planet about 4 times the mass of Jupiter, maybe even with a moon. To learn more about the object, the team searched through data from Keck Observatory and the Gaia satellite. They found the star was located about 24,000 light-years away, so still within the Milky Way. By comparing the location of the star in 2011 and then 10 years later in 2021, the team was able to calculate its speed. Having calculated the speed of the star to be around 540,000 kilometers per second, the team is keen to secure more observations in the years ahead. If it is around the 600,000 kilometers per second mark, then it's likely to escape the gravity of the Milky Way and enter intergalactic space millions of years in the future.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
The US Army is establishing its first ever dedicated space career field for enlisted personnel, a shift that military officials say will better prepare the force for modern conflicts that span land, sea, air, cyber, and space. The new Military Occupational Specialty MOS, designated 40D for Space Operations Specialist, will create a permanent career track for enlisted soldiers specialising in space operations, a senior Army official announced on May 2nd. These specialists will become the experts we turn to during the next conflict, said Lieutenant General Sean Gainey, commander of the US Army Space and Missile Defence Command. The initiative, unveiled last August, has now received approval from the Army senior leadership. Previously, only Army officers had access to a dedicated space operations career path. Enlisted soldiers working in space-related positions were drawn from other specialties such as engineering, air defence, signals or intelligence, often returning to those fields after completing a space assignment. To date, the preponderance of expertise and experience in space operations resides in the Officer Corps instead of the non-commissioned Officer Corps, Gainey said. This new Space Operations MOS will ensure that specialists through Command Sergeants Major arrive at Army space formations with experience and expertise in space operations. The change comes as military planners increasingly recognise space as a contested domain crucial to modern warfare. Army space professionals will focus on tactics to disrupt or interdict adversaries' satellite networks. Army officials said the initiative is designed to be budget neutral. While personnel currently loaned to space units will return to their original fields in air defence, signal and intelligence, their positions will be converted to the new Space Operations Specialty. The move aligns with broader Department of Defence efforts to enhance space capabilities in the face of China's advances in anti-satellite technologies. Military analysts note that as satellite communications, GPS navigation and space-based intelligence becomes increasingly essential to ground operations, the Army's investment in specialised space personnel reflects the growing interdependence of traditional land warfare with capabilities in newer domains. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
A spacecraft launched by the Soviet Union in 1972 is due to come crashing back into Earth's atmosphere around May 10th, and nobody knows where it will land. The Cosmos 482 mission launched the spacecraft toward Venus, but an upper stage rocket booster malfunction left the spacecraft orbiting Earth instead. Netherlands Delft Technical University Space Situational Awareness lecturer Marco Langbroek discovered the spacecraft's return to Earth. As this is a lander that was designed to survive passage through the Venus atmosphere, it is possible that it will survive re-entry through the Earth atmosphere intact, and impact intact, Langbroek wrote in a blog post. He said the risks are not particularly high, but not zero, and are similar to a meteorite impact. Netherlands satellite tracker Ralph Vandenberg said a set of images he obtained shows the Cosmos capsule in Earth orbit. We see a clear compact ball. This set is already fantastic, I think, Vandenberg said. He said the capsule may be tumbling, and in some images it appears to have a weak elongated structure on one side, which could be a parachute that opened during the rocket booster failure. While re-entry into Earth's atmosphere is predicted as soon as May 10th, the actual re-entry could be a few days either side of that date.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
NASA's Juno spacecraft has uncovered striking new details about Jupiter and its volcanic moon Io. By looking beneath Jupiter's dense cloud cover and deep into Io's surface, scientists have developed a more detailed model of the fast-moving jet stream that surrounds Jupiter's North Pole. At the same time, they've achieved a first, mapping the subsurface temperature of Io, revealing important clues about its internal structure and ongoing volcanic activity. Everything about Jupiter is extreme. The planet is home to gigantic polar cyclones bigger than Australia, fierce jet streams, the most volcanic body in our solar system, the most powerful aurora, and the harshest radiation belts, said Scott Bolton, principal investigator of Juno at Southwest Research Institute in San Antonio. As Juno's orbit takes us to new regions of Jupiter's complex system, we're getting a closer look at the immensity of energy this gas giant wields, he said. Although Juno's microwave radiometer was designed to study Jupiter's deep atmosphere, the mission team also directed it at Io, teaming it with data from the Jovian infrared auroral mapper for a more complete view of the moon's fiery interior. The Juno science team loves to combine very different data sets from very different instruments to see what we can learn, said Shannon Brown, a Juno scientist at NASA's Jet Propulsion Laboratory in Southern California. She added, when we incorporated the microwave radiometer data with the Jovian infrared auroral mapper's infrared imagery, we were surprised by what we saw, evidence of still warm magma that hasn't yet solidified below Io's cooled crust. At every latitude and longitude, there were cooling lava flows. The data suggests that about 10% of the moon's surface has these remnants of slowly cooling lava just below the surface. The result may help provide insight into how the moon renews its surface so quickly, as well as how heat moves from its deep interior to the surface. Io's volcanoes, lava fields and subterranean lava flows act like a car radiator, said Brown, efficiently moving heat from the interior to the surface, cooling itself down in the vacuum of space. Looking at the Jovian infrared auroral mapper data alone, the team also determined that the most energetic eruption in Io's history, first identified by the infrared imager during Juno's December 27, 2024 flyby, was still spewing lava and ash as recently as March 2. Juno mission scientists believe it still remains active and expected more observations on May 6, when the solar-powered spacecraft flew by the moon at a distance of 55,300 miles or 89,000 kilometres on February 18, 2023. And it began radio occultation experiments to explore the gas giant's atmospheric temperature structure at that time. With this technique, the radio signal is transmitted from Earth to Juno and back, passing through Jupiter's atmosphere on both legs of the journey. As the planet's atmospheric layers bend the radio waves, scientists can precisely measure the effects of this refraction to derive detailed information about the temperature and density of the atmosphere. So far, Juno has completed 26 radio occultation soundings. Among the most compelling discoveries, the first ever temperature measurement of Jupiter's North Polar stratospheric cap reveals the region is about 11 degrees Celsius cooler than its surroundings and is encircled by winds exceeding 100 miles per hour or 161 kilometers per hour. The team's recent findings also focused on cyclones that haunt Jupiter's north. Years of data from the Juno Cam, visible light imager, and the Jovian infrared auroral mapper have allowed Juno scientists to observe the long-term movement of Jupiter's massive northern polar cyclone and the 8 cyclones that encircle it. Unlike hurricanes on Earth, which typically occur in isolation and at lower latitudes, Jupiter's hurricanes are confined to the polar region. By tracking the cyclone's movements across multiple orbits, the scientists observed that each storm gradually drifts toward the pole due to a process called beta drift, which is the interaction between the Coriolis force and the cyclone's circular wind pattern. This is similar to how hurricanes on our planet migrate, but earthly cyclones break up before reaching the poles due to lack of warm, moist air needed to fuel them, as well as the weakening of the Coriolis force near the poles. What's more, Jupiter's cyclones cluster together while approaching the pole, and their motion slows as they begin interacting with neighbouring cyclones. These competing forces result in the cyclones bouncing off one another in a manner reminiscent of springs in a mechanical system, said Yoshi Caspi, a Juno investigator from the Weizmann Institute of Science in Israel. This interaction not only stabilizes the entire configuration, but also causes the cyclones to oscillate around their central positions as they slowly drift westward clockwise around the pole. The new atmospheric model helps explain the motion of cyclones not only on Jupiter, but potentially on other planets, including Earth. One of the great things about Juno is that the orbit is ever-changing, which means we get a new vantage point each time we perform a science flyby, said Bolton. In the extended mission, that means we're continuing to go where no spacecraft has gone before, including spending more time in the strongest planetary radiation belts in this solar system. It's a little scary, but we've built Juno like a tank, and we're learning more about this intense environment each time we go through it.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
And just in case you thought things were winding down on the International Space Station, they are still very busy up there. 2 NASA astronauts have completed a nearly 6-hour spacewalk to perform maintenance and upgrades on the International Space Station, the agency announced Thursday. Anne McClain and Nicole Ayers relocated a space station communications antenna and improved the ability to generate power on the ISS. Additionally, the astronaut pair completed a pair of get-ahead tasks, including installing a jumper cable to provide power from the P6 truss to the International Space Station's Russian segment and another to remove bolts from a micrometeoroid cover, a release from NASA said. Moving the communications antenna and installing a bracket created space to equip the ISS with additional solar arrays in the future. While the team accomplished most of its tasks, McClain and Ayers were forced to postpone others due to a lack of time and limited consumables. It was the 3rd spacewalk for McClain and the 1st for Ayers. It was the 5th all-female spacewalk performed by NASA astronauts. Thanks for joining us again on Astronomy Daily for the 5th of May 2025.
Oh, Hallie, it's been a fine old episode, hasn't it?
That it has.
So what was your pick of the day today, Hallie?
I think it was the same as yours, human. I know your interest in exploration, probes and so on would make you choose Juno's continuing adventures at Jupiter.
Oh yes, regular listeners will know it's a little bit of an obvious choice for me, isn't it? Just imagine being so far from Earth in that very dangerous place. It's an amazing story, really.
I agree. And we'll find some more stories for you to enjoy soon.
Oh, thank you, Hallie. I'm sure that you and Anna will find heaps for me to be interested in during the week as you do your weekly broadcasts from the Astronomy Daily virtual studio. That's so that all of our listeners can enjoy everything astronomy, science, and space science every day. Anyway, that's enough from us in the Australia studio today.
Time to go, human.
For sure. Thanks again, everyone, for listening in. A big down under g'day to the crew at NASA's Marshall Space Flight Center in Huntsville, Alabama, and well done for all the great work you're doing way out there.
Fantastic. We are big fans.
See you next time.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.